For the first time in history, humanity has captured images of an interstellar object from the surface of another planet. The subject of this unprecedented achievement is 3 Atlas, an enigmatic visitor from beyond our solar system that recently made a close approach to Mars. The photographs, faint and grainy yet profoundly meaningful, were not taken by a deep space observatory or a purpose-built mission, but by the Mars Perseverance rover, a robotic geologist whose cameras were never intended to observe the stars. On October 3rd, 3IA Atlas passed within roughly 0.2 astronomical units of Mars, about 30 million kilometers. That distance, though vast by human standards, is close enough in cosmic terms to make Mars a prime vantage point. Anticipation among astronomers was high. Multiple space agencies, including NASA, the European Space Agency, China's CNSA, and the UAE space program had pledged to record the event using the satellites orbiting Mars. The Mars Reconnaissance Orbiter's high-rise camera, famous for its astonishingly sharp images of the Martian surface, was expected to deliver unprecedented detail of this interstellar visitor. Mars Express and the other orbiters were also poised to make observations. But his days turned into weeks. Not a single official image was released. Instead, the first confirmed visual evidence came from an unexpected source, the Mars Perseverance rover. Operating in Jezero crater, Perseverance occasionally turns its cameras skyward for calibration and engineering checks. On October 3rd and 4th, it took several long exposure shots of the Martian night sky. These images, publicly available through NASA's data feed, overlapped with a section of sky where 3I Atlas was predicted to be. 2 independent amateur astronomers, Simon Schmov and the creator of Astronomy Live, downloaded the raw frames and began the arduous process of image stacking. By combining dozens of individual exposures, removing background noise, and aligning the star fields, they managed to extract a faint diffuse patch of light that was unmistakably the interstellar object itself. This was not an easy discovery. Schmob's composite built from 36 exposures on October 3rd showed only a dim, cloudy blur. The next night, 40 more exposures were captured and processed by Astronomy Live, producing a cleaner image that revealed a central bright spot surrounded by a pale green coma, a glowing envelope of gas and dust sublimated from the object's surface. Against all odds, these images became the first interstellar observation ever made from another planet. The discovery carries both scientific and symbolic weight. Scientifically, it confirms that 3IE Atlas was where its calculated orbit predicted it would be, strengthening confidence in the accuracy of prior measurements. Symbolically, it demonstrates the extraordinary power of public data and collaboration. 2 citizens working with free access imagery from a rover millions of kilometers away achieved what the world's largest space agencies had not yet revealed. The absence of official imagery, however, has puzzled many. Normally, NASA and ISA release raw images from Mars orbiters after a short delay, but in this case, nothing appeared. NASA has not commented, and ESA has remained similarly silent. The most likely explanation lies in bureaucratic and technical hurdles. Processing interplanetary imaging data takes time, especially amid the current U.S. government shutdown, which has slowed operations across multiple federal agencies, including NASA. Yet, the delay has also fueled speculation online, with some suggesting more dramatic reasons for the data blackout. In reality, the explanation is probably mundane, but the silence has nevertheless deepened the mystery surrounding 3I Atlas. As of now, the object has disappeared from view. After its Mars flyby, 3 Atlas moved into a region of the sky too close to the Sun for Earth-based telescopes to observe. On October 21st, it entered Superior Conjunction, passing directly behind the Sun from our perspective. For the next 6 weeks, it will remain hidden in the Sun's glare, completely invisible to observatories on Earth, and even to space telescopes like Hubble and James Webb. Astronomers expect that it will become visible again in early December, assuming it continues along its projected path. 3I Atlas is most likely a comet originating from outside our solar system following a hyperbolic trajectory that will eventually carry it back into interstellar space. Its spectrum and brightness variations suggest an unusual composition, perhaps containing exotic ices or minerals formed around another star. Yet not everyone agrees that it is merely a comet. Some theorists recalling the controversies around the first interstellar object Oumuamua in 2017 argue that a small but non-zero chance remains that 3 Atlas is artificial, a piece of alien technology, perhaps a probe or derelict craft. That possibility is remote but not entirely dismissible. From a scientific preparedness standpoint, even that faint possibility underscores the importance of monitoring such visitors carefully. At present, humanity stands in a peculiar kind of darkness. Not the absence of light, but the absence of sight. We are, for all our scientific sophistication, effectively blind. The only available imagery of the interstellar object known as 3 Atlas comes not from the gleaming observatories that circle Earth or the powerful telescopes peering into deep space, but from the modest cameras of a single rover operating alone on the dusty surface of Mars. Those cameras designed to study rocks and sediment were never meant to capture distant celestial phenomena. Yet, in an irony almost poetic, they have become the sole eyes through which we glimpse this cosmic wanderer. High above the Martian plains, the Mars Reconnaissance Orbiter carries the HiRISE camera, one of the most powerful imaging instruments ever sent beyond Earth. In theory, it could have given us stunningly detailed data on 3I Atlas, resolving the shape, color, and even the coma that may surround it. But so far, nothing has been shared. The data, if it exists, remains locked away in the servers of space agencies. No one outside of those institutions knows what HiRISE saw, if it saw anything at all. If 3 Atlas has changed in brightness, fractured, or begun to outgas more intensely as it draws closer to the sun, we would have no way of knowing. That uncertainty gnaws at scientists and enthusiasts alike. For now, the object has slipped into the blinding radiance of the sun. It will not emerge until late in the year when it reappears from behind the solar glare and once again becomes visible to our instruments. Perhaps by December, the Hubble Space Telescope and its younger sibling, the James Webb, will be able to train their mirrors on it again. Perhaps, too, the European Space Ice JUICE mission, currently traveling through the outer solar system, will capture a faint, distant glimpse in November. Yet, even if it does, those images will likely take weeks, even months, to process, verify, and release. By then, the moment of its closest passage, and whatever secrets it might have revealed, will be long gone. This forced period of darkness has stirred a deeper conversation among scientists, one that goes beyond this single object. It has exposed a sobering truth. Despite all our telescopes, orbiters, and satellites, humanity's ability to monitor the cosmos remains profoundly limited. Our instruments may stretch across planets and into orbit, but they all share the same geometric blind spot: the sun itself. When an object moves into conjunction, passing behind that overwhelming glare, we lose it completely. It is a vulnerability that many have warned about for years. Astronomers and engineers alike have argued for deploying deep space observatories in other orbits, perhaps at Venus's distance or positioned at the far side of Mars, so that when the sun blinds one side of the solar system, another set of eyes can continue watching. In principle, the technology exists. What's missing is coordination, funding, and will. The mystery of 3 Atlas has made this deficiency uncomfortably clear. A visitor from another star has entered our system, and we cannot see it. In the vacuum of reliable data, imagination rushes in to fill the void. Rumors have proliferated, interpretations have diverged, and myths have begun to take root. One image in particular ignited a storm across social media. A long exposure photograph from Perseverance showing a bright, elongated streak slashing across the Martian sky. To the untrained eye, it looked eerily like a glowing cylinder, unmistakably artificial, impossibly precise. Within hours, posts and videos proclaimed it to be the first definitive image of 3 Atlas, an alien craft caught on accident on camera. The excitement was electric, and the fear was palpable. But the truth, as is often the case in science, was simpler and more elegant. The streak wasn't an alien visitor. It was Phobos, one of Mars's two small moons. During the long exposure, Mars rotated slightly and Phobos moved along its orbit, creating the illusion of a bright, elongated shape in motion. Perseverance's camera, in its patient recording of the night sky, had captured the moon's path as a luminous line. Its shape had nothing to do with 3 Atlas.